Hello everyone. For this presentation, we're going to be talking a little bit about engine basics. So nothing really about tractors for this one. I think it's kind of important to know a little bit about engines so we can talk more about the different things in class, why we do the different pre-check things and why we do different things that we do operating machines. So this presentation is really all about just some basic engine stuff, and we're going to, as we go through the quarter, I'll bring up different topics and we'll discuss different just basic engine components, how everything works inside of it, and how that influences some of the things we do when we operate these machines. So internal combustion engine basics, every engine that we're going to be looking at is this kind of internal combustion engine. So we're going to get started. So our basic engine components, we're just going to talk about a couple basic parts of the engine as we go through. So the first one is going to be the block. This is really like part number one on an engine. If you're going to build an engine or put an engine together, you kind of start with the block. So this is the housing for all the other parts on the engine. Everything bolts to this or goes inside this or bolts on it some way or another. This a lot of times contains the cylinders that the pistons move up and down in. So if we look, we see these four different uniform holes on the top. So this is where the pistons are moving up and down within the block. And we'll talk about what the piston is in a minute, but everything bolts to this. It's kind of the most basic part, right? All these different holes and things on this have different components bolted to it. Hundreds, if not thousands, of parts move up and down inside of this or around the outside and stuff like that. So yeah, the most basic part. Part number one when you go to build something or go to build an engine is the engine block. So the next kind of most basic parts are the piston and connecting rod. So the piston moves linearly up and down in the engine. So the piston right here on the top is this portion right here. This I know this is kind of a 2D picture, but this is a kind of a round shape right here. So the piston moves up and down inside the engine block right here. So these holes go down all the way into the bottom of this engine. So that piston is moving up and down linearly in this. And then what's connected to the piston is the connecting rod via this big pin right here. It's called a wrist pin. So the connecting rod connects the piston to the crankshaft. So the crankshaft is the next part we're going to talk about. So anyway, connecting rod. So this will all kind of come together in this next slide here. So right down here in the bottom, we have our crankshaft. So we have our piston right here, right? Our block, it would be wrapped around all this, but it's kind of taken away in this picture. So our piston is moving up and down, and the crankshaft is taking that linear motion of the piston moving up and down and turning that into rotation. So as the piston goes up and down, the crankshaft is rotating via the connecting rod, right? The connecting rod connects our piston to our crankshaft. If we look at our crankshaft right here, this part right here is kind of where it bolts to the engine block. This is called a main journal, right? It's a journal bearing. So the main journals are the bearings that hold it into the block. And then we have our rod journals, which are these right here, right? They're going to name that because they are the journal bearing where the connecting rod connects. So anyway, that's kind of how this goes. So this is rotating around while the pistons move up and down, and all of this is bolted inside the block. On the other side of where the piston and connecting rod connects on the crankshaft, there's kind of this big lobe back here. This is called a counterweight. So it's meant to oppose the weight of the piston. As the piston goes up and down, this is kind of going the opposite direction and trying to balance out vibrations and stuff like that. So counterweights offset from the piston to kind of counteract, right? As the piston goes up, that counterweight's going down and vice versa. So yeah, the crankshaft. All right, so those are kind of the basic parts that I'm going to leave you with. We'll talk about some of the other parts to as we go through. But now I want to talk about the kind of process or the cycle that an engine is going through as it's running. So most of the engines well, pretty much every engine that you guys are going to be used to in like a car or a pickup or really pretty much anything is going to be a 4-stroke engine. We'll talk as well in this lecture about 2-stroke engines that are going to be a little bit less common, but this is going to be the we're going to go through the 4-stroke cycle that is going to be, you know, what you're going to see in most all modern engines. So as kind of denoted by the name 4-stroke cycle, we're going to talk about the 4 different strokes of this engine. So when I talk about a stroke, it's really the piston either moving down or up is considered 1 stroke. So a stroke, this one is going to be the intake stroke. So as in this setting, the piston is moving down and there is a valve opened that is allowing fresh air and fuel mixture into the cylinder. So as the crankshaft is rotating down here, right, the piston is moving down, right, our crankshaft is rotating this direction, piston is moving down. It is pulling in air through the intake valve down into the cylinder and the combustion chamber up here. So piston moving down, the intake valve is open, and it is allowing fresh air and fuel into the cylinder. So that's to be the first stroke in the 4-stroke cycle. So number 2, so once the piston gets all the way down to the bottom, that intake valve closes, right? So we come back to this. So once the piston gets all the way down to the bottom and the crankshaft is down here, the intake valve will close, and then this keeps rotating this direction, and then the piston has to come back up. So the next stroke is going to be our compression stroke. So the crankshaft is now over here pushing up, and we are compressing. Neither valve is open right now, so we're trapping all this air and fuel in here, and we're compressing it. Piston comes all the way up to the top, and that is going to be, I don't know, when it's all the way compressed. So again, none of the valves are open. We're compressing all the fuel and air as the piston is moving up. So that's the second stroke, is compression. So once we get all the way up to the top, the crankshaft kind of comes over center. The piston is going to be moving back down, but right as soon as the piston is up here at the top, we ignite our fuel and air mixture. So with a gasoline engine, this thing right here would be a spark plug. So it has a little electrical spark that ignites the gasoline and air. And it is now, the piston is moving down, but it's being forced down. So this is our combustion, or more commonly called our power stroke. Right? This is where all the power of our engine comes from, is this combustion forcing the piston back down. So now the crankshaft is still moving this clockwise direction. It comes kind of over the top, and then this is when our peak cylinder pressure happens when we are ignite that fuel and air, and we are forcing the cylinder down. Our valves are still closed at this time. Right, we have to trap all this compression or this pressure in here and force our piston back down. So that's our third cycle, is the combustion or power. So one more, our last one. So our power stroke is pushing our piston all the way down to the bottom, and then we have to let all that, the exhaust out, right? All that is burnt fuel, and there's not a lot of oxygen left in there, and all that sort of stuff. All are just kind of wasted gases. So, or not necessarily wasted, but all our exhaust gases. So number 4 is our exhaust. So as the piston is forced all the way down, it comes across the bottom, our exhaust valve opens, and our piston comes back up and forces all the exhaust gases out through the exhaust of the engine. So our piston is moving back up again, and our exhaust valve is open, forcing all those gases back out. And that's the fourth, the final stroke. So after this, it's basically, it repeats this 4-stroke process. So it's kind of all of them together, right? Again, we have our intake as the piston's coming down. Crankshaft is always rotating clockwise. Right, piston's down, let's fresh air in, compress it, power, and then exhaust. And then we come back and go intake, compression, combustion, exhaust, and keep repeating this process. So something I want to bring up a couple questions that is going to pertain to when we kind of compare four-stroke and two-stroke engines. So one, how many crankshaft revolutions per cycle? So in the four-stroke cycle, the crankshaft revolves twice to get through this whole process. All right, so we have one rotation. Well, basically each stroke is half a rotation, right? The piston coming from top all the way to the bottom, or bottom all the way to top. That's basically half a revolution, right? So we get 2 crankshaft revolutions to get through this entire four-stroke cycle. Um, and then this is going to kind of pertain to when we talk a little bit about two strokes versus four strokes again. Is there ever an instance where the intake and the exhaust are, where the intake air is open to the exhaust? And in a four-stroke engine, in a stock application, no, there really isn't much time when the intake is open to the exhaust. So that's we're going to talk about why that's important when we talk about two-stroke engines. But there's never an instance where raw fuel is open to the exhaust. That's where a lot of pollution can come from, and why why some engines are banned nowadays. But anyway, there's never really an instance where raw fuel is allowed out the exhaust, because there's never an instance where the valves are both open at the same time. So this would be no. All right, so that's your kind of basic four-stroke engine. And again, just kind of looking at this diagram, we're talking about our piston moving up and down in our cylinder, our crankshaft and connecting rod right here, and then our block is kind of this housing where all of this is. Up here would be what's called the head, and that's where all your valves are, which we'll talk about later on in different lectures. But our block is kind of this housing, crankshaft, connecting rod, and piston right here. So, all right. So that's our basic four-stroke engine. So we're going to talk a little bit now about a two-stroke engine. So two-stroke engine cycle is a little bit different than, well, it's entirely different than a four-stroke engine. So this is kind of difficult there's a couple different things going on with the two-stroke engine. So number one, we're going to talk about basically the two different strokes is the upstroke and the downstroke in the two-stroke engine. So for now, it's going to make a little bit more sense when it's all together. But anyway, so number one, the upstroke. So when the piston moves up in a two-stroke engine, the volume inside the block or the crankcase, it's kind of the same thing. The block is kind of the housing, or you can call it the crankcase. As the piston moves up in a two-stroke engine, the volume down here increases. All right, so that is pulling air and fuel into the crankcase down here below it. So when we think about a four-stroke engine, all the intake air and all the air that's being drawn into the engine and compressed and pushed out is happening above the piston, right? There's no intake or exhaust air open to the bottom of the crankcase down here or in the block. So it's different with a two-stroke engine, but that's how a four-stroke engine works. So two-stroke, as the piston moves up, the volume below the piston increases, so it pulls the fuel and air in below the piston. So the second, the downstroke, because now when the piston is moving down, the volume decreases below it, and air and fuel is pushed around what's called a transfer port up above the piston. So the downstroke is taking the compressed fuel, or not compressed fuel and air, it's just taking the fuel and air that's below the piston and pushing it up to the top. And if you kind of look in here, there are no valves on the intake, right? This could kind of be considered the intake valve and the exhaust. Well, really, they're just ports. They're just openings. So the air and fuel that comes up to above the piston is open to the exhaust. There's just you can just go straight pass through right here. So anyway, when the piston comes down, it brings the fuel and air back up to the top. And then as the piston comes back up, kind of go back to this number one, it is compressing the fuel and air up here, and then the ignition happens. The spark plug fires that. But as it's compressing all that fuel and air, it is drawing more in, and then we kind of go back to the downstroke where as it comes down, it pushes it up around to the top, and then we kind of keep going like this. right? So this kind of brings it all together. Again, upstroke brings the fuel in underneath it, downstroke transfers it around, and the upstroke is compressing it up here as well. So now looking at a two-stroke engine, is there ever, well, I guess we'll think about this. How many crankshaft revolutions per cycle? So with a two-stroke engine, one revolution of the crankshaft gets you through the cycle. Um, so it's a little bit different, right? Instead of two crankshaft revolutions with a four-stroke engine to get through one complete cycle, we only have one. So that's a little, makes valve timing or ignition timing a little bit different when we think about four-stroke versus two-stroke engines, but we'll talk about that later. So is there an ever instance where the intake air is open to the exhaust? So with a two-stroke engine, yes. Anytime the piston is coming down and we're basically pushing fuel and air up above the piston, it's just completely open to the exhaust. So every time this happens, there's just an amount of time where the raw fuel and air can get in and out of the exhaust. So this is kind of can cause a lot of pollution and stuff like that. And we'll talk about why that's important later. But two-stroke engines tend to pollute a lot more than four-stroke engines. All right, so a little bit of a comparison between the two. So the earliest form of gasoline engines was a four-stroke cycle, and that is really, it hasn't changed much. I mean, the cycle doesn't change. That's pretty much the standard as we go through. Two-stroke engines came along a little bit later, but they are super simple. So if we kind of come back to this diagram, there's no complicated valves or anything that open with the intake and exhaust and things like that. They're super simple. All we have is this little, kind of like a little trap door that lets fuel and air into below the crankcase. And when the piston comes down, it just pushes the fuel around and that sort of thing. So this little valve right here is super simple. So when we think about a four-stroke engine, we have these intake and exhaust valves that have to open and close at the proper time. And it's kind of a complicated setup up here. This is a lot more, there's a lot more moving parts and things that need to happen at the proper time to make this happen. So for that reason, a two-stroke engine can be very simple and very cheap. Um, so four-stroke engines kind of started the world of gasoline engines, and two-strokes came along a little bit later, but are super simple. So currently the industry standard is four-stroke, and you can, four-stroke engines kind of run the gambit of different fuel types. Pretty much all different types of engines are this four-stroke cycle. So gasoline, diesel, propane, natural gas, any of those different fuel types run in four-stroke engines, or just different types of engines that can run those different fuels. Two-stroke engines, pretty much nowadays you only see these. It's really the only kind of type of two-stroke engine you'll see out there. The fuel is a gasoline and oil mixture. So why it's that way is because down here, you need to be able to lubricate all these different parts that are spinning around inside the crankcase. So there's the crankshaft and connecting rod. All these bearings see a lot of revolutions, and if that was just metal on metal, that wouldn't last very long. It has to be lubricated. Um, but because our fuel is coming in through here, we can't just have like an oil bath down here that this is sloshing around in, because that would, kind of arbitrarily mix oil into this engine, the fuel. So basically with a two-stroke engine, you mix the oil into the gasoline. So that's another big reason why these things pollute so much, is every time we have the ignition, we're not only burning gasoline, but we're burning oil as well. And burning oil pollutes a lot, right? That's why when you see a two-stroke engine, if you're familiar with those at all, that you see blue smoke coming out of them. Even when they're running good, you see they're burning oil, so they smoke quite a bit, and that's really why they pollute so much. Back in the day, they made GMC and General Motors made a lot of diesel engines for a while, industrial diesel engines that were two-stroke engines. But that pretty much doesn't happen anymore, or that's in most settings that's banned from not just production for most applications, but you can't even run a two-stroke diesel engine in California anymore because of emissions standards. So a lot of even the bigger diesel engines are running into much more. There's a lot more laws going into place that are requiring different emission standards as far as pollution and stuff like that. And these two-stroke diesel engines that were built for the long time in the 60s and 70s, you're not even allowed to run them at all anymore in California. So anyway, um, two-stroke nowadays, really the only uses for them are going to be kind of small engines. So you'll see like weed eaters and chainsaws and kind of like uh, lawn care implements or tools and stuff that use these two-stroke engines. Pretty much everything nowadays that has an internal combustion engine, a diesel or a gasoline engine or anything like that, is going to be a four-stroke cycle. And really, it's all driven kind of by this pollution regulation type things. Government isn't allowing manufacturers to produce two-stroke engines anymore because of pollution. So it's not really because they're outdated and four strokes are better. I mean, two strokes are super cheap and super simple. So they kind of have that going for them. But anyway, uh, they're being banned because of emissions standards. So that's kind of our basic engines lecture here. So we'll go over talk about more components and how they work as we go through, and talk about how this relates to driving and operating these different machines as we go through this quarter. But that is kind of our most basic conceptual explanation of what's going on with these engines on the tractors and that sort of thing.